Hi, my name is Professor Gareth Arnott and I'm the Program Leader in the Department of Chemistry and Polymer Science based here at Stellenbosch University. I just want to spend a bit of time talking about chemistry, particularly our programs that we offer here, should you be interested in coming to study with us. One of the things that really fascinates me is this statement by Bill Bryson. What I love about it is just the fact that, if you take say the human body, and you have to take all the atoms that are involved in the human body, and you kind of take them apart, what you're left with is just a bunch of nothing. It's just some atoms and some gases, and at the end of the day, you have nothing there. Yet, if you put them together in a particular way, you get life. You get us, and you get all the materials and things that you see around us. And that really drives the thinking of chemists in the world. Now, chemistry, we speak about it being the central science. The reason we do this is because chemistry has an impact in so many different spheres, as you can see on the slide here. From medicine to geology, physics, biochemistry, and many other places are all influenced and have some grounding in chemistry. And so chemistry supports all of those, and some of them are supported by chemistry as well. The United Nations have 17 Sustainable Development Goals, which they released a few years ago. And of those 17 goals, there are 7 of them which are directly impacted by chemistry. And so chemistry has a huge part to play in our world today. Chemistry is the thing that is needed to create the fertilizers to affect zero hunger. Medicine, for good health and well-being, medicine is highly impacted by chemistry, developing new drugs, developing new medicines that can help and save us from the diseases that we have to deal with. Clean water and sanitation, and the list goes on, as you can see in front of us. All these places where chemistry is having a huge impact. One of the questions I get asked all the time, though, is that, what can you do with chemistry? So I have this little cartoon here that says, so what would you like to be one day? And the kid answers, employed. So that's a question that we always get with chemistry. It's like, well, if you study chemistry, am I going to get a job? And the simple answer, and of course it's a complicated answer, the simple answer is, well, yes, society needs good chemists. And so up here I've got a list that is by no means exhaustive, but a whole bunch of different jobs that people go into that involve chemistry. Everywhere from cosmetic scientists to nuclear scientists, material scientists, chemical engineers, pharmaceutical chemists, process chemists, and the list goes on and on and on. There's a lot of areas that involve chemistry. So what would you do if you came into Stellenbosch University and you wanted to study chemistry? Well, the way we've set up our chemistry degrees is that we have 4 main, what we call focal areas. So you'll see this term in Stellenbosch University all the time. And I just want to briefly outline what those 4 focal areas are, and then also let you know that there's this mystery 5th one, and I'll talk about that right at the end. So the first one I want to look at is applied and sustainable chemistry. Now, very simplistically put, the applied and sustainable chemistry focal area is essentially a pure chemistry focal area. We'll be doing all the main chemistry subjects, and then we have a number of applied modules that we put on, including a green and sustainable chemistry module, which looks at the impact of chemistry in society and how chemists can solve the problems that we have in the world that need to be solved through chemistry. But we also have subjects on polymer chemistry and also applied medicinal chemistry as well that get put into that focal area. The next focal area is chemical biology. Now, the chemical biologists is really, for simplistic sake, it is a double major between biochemistry and chemistry. And so what we're looking at here is that interface between those 2 subjects. So this is for people who are interested more in the bio side. People who are interested in medicinal chemistry would also kind of choose this, focusing a little bit more on the biochemical side. And at the end of this degree, you can go on and do an honors in either biochemistry or chemistry. The next one is a new focal area called chemistry with chemical engineering. Now, this is a very interesting focal area. So what happens in this focal area is that during the 3 years of doing your BSc, where you'll finish with chemistry, you also do chemical engineering subjects. And at the end of your third year, you can graduate with a BSc of chemistry, and then you have two choices. Your one choice is to continue with honors in chemistry. The other choice is to move over into engineering, to chemical engineering, and continue there, starting at their third year, moving on to their fourth year and finishing with a BSc Chem Eng. So what this allows you to do potentially is within 5 years to obtain both a BSc and a Chem Eng degree. The chemical engineers are very excited about this because students who have a strong, chemical engineering students who have a strong background in chemistry are highly sought after. So that's quite excellent. And we're also interested in how chemistry and chemical engineering are connected with each other. So if you're interested particularly in chemistry, chemical engineering, and you think you really, really like chemistry, I can strongly recommend this as a starting point. We then have a focal area called chemistry and polymer science, and I need to be clear here that this particular focal area does not necessarily involve polymer science. The reason it's called chemistry and polymer science is just because we are the department of chemistry and polymer science. We have a world-leading research area in polymer science, and so we have that in our name. This focal area is really the catch-all for whatever you want to do. So you can do chemistry, and you might want to do microbiology as a second major. You could do chemistry and you might want to do geology as a second major. You might do chemistry and have mathematics or physics. So there are a lot of options within that focal area, and you can find out more within the yearbook about that. And then we have the mystery, and the mystery is applied medicinal chemistry. Why is it a mystery focal area? It's because it's not directly housed under chemistry. It is an interdisciplinary degree, and essentially it is a double major between chemistry and physiology. So at the end of the applied medicinal chemistry degree, which focuses on, again, sort of the interface of medicinal chemistry and with physiology, it allows you to have either an honors in chemistry or an honors in physiology. And so it's similar to the chemical biology in one respect, but the chemical biology is focusing more on the biochemical pathways involved in medicinal chemistry and other things, whereas the applied medicinal chemistry is focusing more on the physiological aspects as well. And both are very, very interesting and popular focal areas that get chosen. All right, so what do you need to do to get into chemistry? We need a strong mathematical background. That's one of the biggest things. So 70% in maths, I think that's a 6. Nowadays, and then in physical sciences we only require 50% or 4. All right, what happens after BSc? So typically many people come in and they, again, we go back to the job market thing, and you say, okay, what am I going to do after 3 years of studying a BSc? Well, we need to be realistic here. After 3 years, you are not a chemist. You shouldn't be too sad about that. This is not strange. After 3 years, you're not a doctor. After 3 years, you're not even an engineer. Engineering requires at least 4 years before you become a professional engineer. And it's the same in chemistry. If you wish to be registered as a chemist with the South African Chemical Institute, you need to have at least 4 years. And so you would need to do an honors degree in chemistry if you wanted to pursue a job that is specifically chemically related. What we find though is that our honors class are so excited about studying chemistry that many of them actually just continue on and to do a master's and then a PhD later on as well. So that's all I have to say. I hope to see you in chemistry next year, and good luck for the rest of your matric exams.